wireless headphones. And the headphones, guess what? It is tuned to a radio station. Technology existed before you were born, man. Right? The headphones can be tuned to a radio station. I was blasting the music every time. Hey, have you gone to this kind of place called a jamming studio? No. It's a musical studio with all the amplifiers, the guitars, the bass, the drum. I go there almost every week. Then we just start. Now I just singing every few hours. I'm quite afraid my eardrums are already there. So please take care of your eardrum. Very important. Alright? Okay, guys. The most important thing about these two paragraphs is the word displaced. When you look there, right? Air particles are displaced, water is displaced. Once I have a vibrating source, which is placed in the medium, the particles in the medium will be displaced. But by saying displaced, am I saying the particle is taken out of the medium? No. What happens to the particle? It just, can we use certain physical terms, physics terms? What is the exact meaning of displacement? Is it removed out of the medium or what?
Remove from its rest position.
Say again?
Rest position.
When I say particles are displaced, it means that it moves, it moves or they move in a periodic motion about its rest position. Can someone remember what is the meaning of periodic motion? Can you use your finger and show me what's periodic motion? My hands. Right? What does this remind you of? Can this be a periodic motion? As long as it's repeated at regular intervals, it's called periodic motion. This is chapter, actually this is chapter on waves. Okay guys, I will not go through anything on this slide. It is all in your book. Okay, this is the part where I want to start. I did not bring my slinky because first of all my slinky might be a bit too fast for you to see. But when I'll bring it when everybody is here. When you move a slinky this way, what happens is that you see that there's always this group of I don't know what I call it. Coils. Okay? That will be moving like that. Right? And you see that this group of coil, they are compressed. We give them a very special name. We call them a compression. Okay? Then you also see a group of coil that is spread out like that. We call this a rarefaction. Not fraction, rarefaction. In any longitudinal wave, there are always two different types of grouping. One compression, one rarefaction. And I want to highlight, or I cannot emphasize enough these few words, as a series of compression and rarefaction. Is this in your book? A series? Note this down and I want you to take about 10 seconds to digest what is the meaning of a series of compressions and rarefactions. You have time to think about it? Okay, now let me ask Kit, what is the meaning of a series of compression? Anybody has something different to say?
They always come together.
Always come together. A set of. Actually, sorry. It comes from after another relation. How many? One. Bella, what is your understanding of a series of conversion reaction? Comes in a repeated sets. Is it okay? Actually, the answers are merge them all together. It gives you a very good picture. What it means that when you have a series of C and R, it tells you that you cannot only have one C and one R. In any complete sound wave, between the transmitter and the receiver, you know what's the transmitter, right? The source R. The receiver is the one that hears, right? Between the T and the R, there are always more than one set of C and one and R. What you get is this. This is what we call a series of compression. Right? Actually, to me, this looks like a kind of graph. You know what kind of graph this is? This is exactly the sine. What's the sine graph? You know, right? Do you see that all the wave chapters are coming like that? Now see. Do you know that light waves are also like that? You know, right? Do you know that light waves are waves, but they're also particles? I don't know that much, but it's just like that. So all the waves they coexist as this form. Right? Now the question here is, what happens if what happens if you remove half of the C and R? The receiver will never hear the sound. Okay? In order for the receiver to hear the complete sound of everything, it has to reach the receiver. Okay? Now, next part. This is the part where slightly, you need to be able to understand this quite clearly. Compressions are regions where the medium density is higher than the surrounding density. Rarefactions are regions where the medium density is lower than the surrounding density. Note this now, I think it should be in your book. Oh, okay. Let me explain to you why air pressure. Why did the book write air pressure and on my slide it says medium density? Hey guys, can sound occur only in air? It occur in any medium, right? So air is just an example in your textbook. In general, air can happen in any medium. That's why they say medium. Let's say now we are talking about sound being transmitted in your tabletop. Right? Let's say the particles are now heavily just like that, placed in the regular fashion. This is how the particles look like. They are all placed in a regular manner. When I start to displace this layer of particles, these particles move inwards. Right? What happens to this region? Let me just take a look. What happens to this region? It's now being compressed. What happens to the density? What do we recall by density? It is the mass per unit volume. I have more mass now in the volume, in this particular volume. My density increases. Compressions are regions where the density is higher. Make sense to you? Right. Now guys, you come to a point where this red thing, after move backwards. Let me show you how to move back. I have passed on, then I move backwards. What happens to the density here? Low, right? Do you call this a compression or rarefaction? Rarefaction is a region where the medium density is lower than the surrounding density. Where is the surrounding? Which one is lower? This one is not. So the benchmark is the surrounding, which is this. Compression happens when the particles are being squashed. Rarefaction happens when the particles are being pulled apart. Make sense to you? Right? This is what I see in your right? Okay, can you clearly see that the air is air? I talk about this air, right? The air particle is squashed here, and this is a region of high or low pressure. High pressure, and this is a region of low pressure. When I say low, I am comparing with what? The surrounding. The pressure of the air that is undisturbed. I will not test you this. The sequence, I will not go through the sequence. You should go it by yourself. Okay? I will try to finish this up. Then we can go how many more slides? Wow, so many. Yeah, I don't go. Tired? Yes. Okay, I will finish. 2 slides, done. This one and the next one. Okay. Pressure distance graph. Now, we always talk about graphs in waves. And someone tell me, is this anything different from what we saw? Travis, why is it not different? Why is it the same? Basically, what you do is to take this and translate it into a graph. Right? Now, can you imagine? This is an MRT train. Where do you not want to be at?
The very front. In the carriage.
Now, obviously, not in the carriage, but if you are in the carriage, where do you not want to be? Be at the sound of the joints. You want to be? Can you see Robert? You do want to be caught in the compression, right? Where exactly in the compression? Why?
Why you say eyes?
At least, if you are here, you still can escape, right? If you are here, good luck to you, right? Okay. Now, at this point itself, you are going to experience the highest relative air pressure. Alright? But where would you want to be at? You want to be in the middle of a compression, which is coincidentally the lowest air pressure. Makes sense to you? So can you see that other than telling you where is the middle of compression and where is the middle of rarefaction, what does this curly arrow tell you? What do this curly arrow tell you? Right? This tells you that, guys, listen up. Anything that is above surrounding air pressure is called a compression. Anything that is below is called a compression. Make sense to you? What did S drag? What did S drag? You don't know what the hell. Okay, guys, this is the last slide. I promise you it's the last slide. Now, You know why he knows? Obviously not because he studied. If he studied, you do much better, right? But because he understood what is the meaning of amplitude, which is good. It's what we want. Alright? Amplitude is the maximum displacement of a particle from its rest position. However, ladies and gentlemen, what is the y-axis that we are talking about? Are we talking about displacement or pressure? So can we say that this is amplitude? But we can say that amplitude is the maximum pressure. But guys, is it enough if we say maximum pressure? Is that something else? If there's enough, here, what is this? The minimum pressure. So in your book, can you please take a look? Take a look. This maximum pressure is minimum pressure. Okay, you can just say maximum pressure change. Same, no problem. Change doesn't matter whether it's positive or negative change. You can follow this also. Good. Good. Okay. They ask if they can we just